Okay, welcome back everybody. Let's follow up on that previous video and let's jump in here and let's look at some examples using heap memory. What I'm particularly focused on in this video is to be able to look at how we can allocate memory on the heap, and that we could do so for various different data types, including data type primitives like basic data type primitives built into C like integers, floats, characters, as well as being able to look at more sophisticated data types such as arrays, strings, structures, arrays of structures. Okay, they really all fall in the same basic premise, right? But they're worth taking a look at least briefly how to do so, right? And understand kind of what the syntax, how to interpret it, as well as how to apply some of this knowledge. Okay, so let's jump in. And this first example here is pretty similar to what we've already seen previously, as a nice kind of recap on how we go about allocating memory on the heap. So if you remember, we want to think about using heap memory in terms of a three-step process. We want to allocate the space, then we want to use it for whatever we need to do, and then we want to deallocate, free it at the end. Okay, so we got this basic example here where, just to kind of recap from a previous, following up on the previous video, that we're passing in the number of bytes into malloc, okay? And what we're going to get is we're going to have space for an integer, okay, on the heap. So this is our heap memory here, okay? So our heap memory, and we are passing in, or we're going to have a pointer that is going to point to that address, okay? And when we're done, we have that step 3 after we use all this is we're going to go ahead and say, hey, we don't need this space anymore. We can go ahead and deallocate that using the free function, step 3. Okay. A couple things to note, right? How we would use this space. Anytime we wanted if we wanted to write something to that space, we would have to dereference the pointer so that we're walking to that address, that we're following that address where the pointer points to, hence star and the pointer, and then we can put whatever value we want in there. So that would write value 5 into that heap memory address. Okay? All right, we've seen that before, and if you understand that, that's the basic premise. We're going to kind of continue on and follow on to some other examples. I also want to point out here that if we wanted to use this is the same idea for other types of data type primitives. If we were going to use malloc and we wanted to do it for, say, storing a double, it's going to follow pretty close to what you would expect with how this would work. So, like, give you an example here is if we go here and we wanted to allocate space for a different type of, like, say, a double, well, we're going to use malloc again for memory allocation. I'm going to use size of so that I don't have to constantly keep track of the number of bytes for different data types, as well as to make the code more readable and portable. Okay. Size of double. Okay. And I'm going to get a pointer. Okay. I'm going to store it as a double pointer. Okay, so I should include the star here. Don't forget the asterisk, okay, to make it a pointer. All right, and we could set this. Malloc is going to return a pointer. Right, malloc's going to return a pointer. We should also include here the fact that we are going to typecast that to a double pointer. Okay, so that would be the way of allocating space for a double on the heap, or any other data type for that matter. Okay, so it's all following the same basic pattern, where we're just, the only things that we need to change is this, and that. Okay, and that should be pretty obvious. I don't think there's anything really confusing about that. Now, let's take it a step further, though. I think it's really worth looking at a couple specifics related to arrays. Right, so, if we recall, an array already, when we're using arrays, okay, when we're using arrays, an array is already a pointer pointing to the start of the array. Okay, and we've seen that before, right? Where we have an array is a pointer to the first address of the array. So if we have an array of size 10, it's going to be array index 0 all the way to array index 9, where the term array is literally a pointer to the start of that array. Okay? So we've got something similar here, like how when we're creating it on the heap, we're going to use malloc. Okay, and we need to not just declare it for a single integer, but it's important that we're declaring it for an integer, a certain number of integers. So we have size of, so if the number of bytes it requires to store an integer is 4 bytes, we have 4 bytes, and then we're going to multiply that by the size so that we have 40 bytes. It's the size to store that entire array that we want in the heap memory region. Okay? So notice the big difference over the previous example is we're multiplying it by the size that we want for the array on the heap. Now, one thing we'll see later on, I'm not going to do it in this video, is we will follow up on this at a later point, and we're going to look at how we can actually resize the array while the program's running. So if we want it to continue to grow or shrink based on what's happening, we're going to be able to do that, but we're going to need to learn something else to be able to make that happen. Okay? All right. If you understand that, and then after that point, things work just the way that you would kind of expect. When we're done using the array, we want to free it, okay, by just passing in the address of the start of the array. That will free that entire block, the entire block of memory that stores the entire array. And to use an array, we're going to deal with it in a way just like what we've seen before. It's an array, and then whatever the index is, okay, and then whatever value you want to write, okay. We don't need to have like the star dereference operator like we've seen in the previous example, because this syntax here of using the square brackets automatically dereferences the pointer. Okay, it automatically dereferences the pointer. So it's implied, it is not needed. Okay, you're not going to actually use the star operator. Okay. All right, let's move forward and look at a similar example but using strings. Okay, let's say we wanted to store a string of size 10. This is going to work the exact same way as the arrays. We got one difference though, is just don't forget that we need one additional space for, oh, and this is a typo here because we're dealing with a character pointer. Okay. Don't forget that we need one additional space for that one additional character for string for the null terminator. So if we want to store 10 characters, make sure that you add that extra one because we need that null terminator to designate the end of the string. Okay, just like we would need normally on the stack. There's really no difference there, but it's a very, very easy thing to forget. Okay. Other than that, it's going to work the same way. Okay, the same way. Okay. So notice here, we're saying we need, if we have a character, if storing a character takes 1 byte, okay, we want to store 10 characters for a string of length 10. We've got 10 characters for that string plus 1 for the null terminator. Okay. All right. Structures. So we can define our own data types. For example, doing this here with structures, we're defining our own data type, and we're defining a data type that is of type student. So we're saying, okay, we want a data type. We want to define that data type as type student, and a student is going to contain space for a name, age, and GPA, hypothetically, just for the sake of this example, right? Storing those 3, the student's going to encapsulate those 3 pieces of information, okay? And to do that, and once again, be careful of these typos here, is this is a student pointer, and this is going to be typecast of type student. Okay. All right. If you understand that, how that space is allocated for us, right? Keep in mind we're passing in here the size of the size of, is going to automatically determine the number of bytes, okay, for a student structure. Okay, very helpful, because otherwise you got to figure all it out. You got to say, okay, there's this many bytes. We're gonna need like 32 bytes for the name string, plus 4 for the age, and then a certain number for maybe 4 more for the float, right? When we got to add all those up, and makes the code very easy to make a mistake, very easy to have a bug, makes the code very unreadable versus just saying size of student. Okay. Now, if you get that right, then we would use the structure very similar to what we've seen in the past. What we would do for applying that knowledge, though, is we do need to make sure that we are dereferencing it. So we would dereference the pointer, and then we'd be able to get each attribute. So if we wanted to set the name, okay, say 20, I'm sorry, the age to say 20, we'd go ahead and do that. And that's because the pointer that we have, okay, the pointer is pointing to something of type student that contains a name, age, and GPA. Right? So we need that star, because the star is saying go to where the pointer points to, and then the dot saying, well, I want the age or the GPA or the name. Okay. Now, just to tie this back into something that we've seen before, okay, star pointer dot age is the exact same thing as saying this. I could also do that with the arrow symbol, right? Dash greater than sign. That's the exact same thing, right? It means dereference the pointer and then using dot notation. Okay. Keep that in mind. That's why it's very important to remember the data type that you're working with, right? If it's a student pointer, you have to dereference it to be able to access the student structure. If it's an integer pointer, you have to dereference it to access the integer, right? So it's very, very important. Keep track of the data types. You want to know what data type are you working with, and then if you understand that, you'll understand how to kind of operate on that, right? On that data type appropriately. Okay. We can also, I got to correct this one too. Okay. All right. That if we've got a, we can make an array of student structures, and then it's going to work the same way as other things have in the past. So this malloc operation here, what that's going to do, right, is we're going to have this array, and that array, just like before, it's going to point to, right, an array, the beginning of an array, right? It's going to point to that first address of an array. Each element, right, each one of these elements here, if we were going to kind of zoom in on one of these, right, it's going to contain, each student is obviously going to have a name, an age, and a GPA. So it's going to contain each one of those data types at every location in the array. Okay, so because of that, it's going to operate kind of similar to some of the other examples, right? If we were going to, just in the interest of space, I'm going to make some room here. If we were going to look at that array and say, in that step 2, saying use heap memory for that array, well, how would we do that, right? We're going to say array, then whatever the index is that we want to get, okay, and then dot, and then whatever the field is, right? So whether it was age or name or GPA, okay. Notice I don't want to use this or the dereference operator, okay? These are not needed or should not be used in the context of arrays, and that's because this square bracket notation implies that the dereference occurs, okay? That's already implies the fact that we go and walk from the pointer to where the pointer points to. So that we've already done this walk of the pointer to where the pointer points to by the nature of the square brackets. Okay? So we do not use, for arrays of structures, right? We use the dot notation, right? We're using this, okay? We are not using the arrow or the dereference operators, okay? Because it's implied. All right, I'm going to stop the video there so that we can keep it a bit short, and then we will follow up on this video. We'll look at some examples of using stack and heap memory in different ways we can solve the same problem, and it was so we can really try to get at the limitations of stack memory as well as the advantages and disadvantages of both stack memory and heap memory. Okay, all right, feel free to ask questions, and thanks for watching.